All right, hello once again. Jeff Scott of Rankin Technical College. We've been talking databases from our Opal book. We're in the middle, toward the end of Chapter 11 of 12 that we're going to go over. What I did while I started to tape and was producing the video I just created was I came back into the employees table, and as I promised, I added a manager ID right here. So you can see when I added it and did a select star, it became null because we had no manager IDs. So I went back in and updated each one of these. So when I got done, other than Paul Knott, everyone reported to somebody. So if you notice in here, for Jeff Scott, Brady Williams, Colin Fugner, hopefully I'm pronouncing that right, Colin, Dominic Schmidt, Valerie Sandbrink, and Charles Corrigan all report directly to Paul Knott. All right. Amin El Hassan reports directly to Jeff Scott. Tiffany Harris reports directly to Brady Williams. Ivy Zettler reports directly to Colin Fugner. Let's see. Ethan Wilson reports directly to Dominic Schmidt. And finally, Evan Resnock reports directly to Valerie Sandbrink. All right. And Charles Corrigan reports directly also again to Paul Knott. Paul Knott reports directly to no one. So I went in and ran a few queries and finally ended up getting this. This is a self-join. So what it's saying is, Jeffrey Scott, these are the employee IDs. All right, these are each employee, and these are who each employee reports to. Now you'll notice there's only 11 records because we don't have a manager for Paul Knott. And you can notice again that Scott, Williams, Fugner, Schmidt report direct, and also Corrigan report directly to Knott. Harris reports to Williams, Sandbrink reports to, I guess she does to Knott also, El Hassan does to Scott, Zettler to Fugner, etc. The point is, what I have done here in this example is I have joined the employees table onto itself, a self-join, to get the information that I was looking for. And sometimes that is the only way to get the information you are actually looking for, is to join a table onto itself. Probably what would have made this a little bit nicer query, and I'm just going to bring it up here one more time. I think it's E2. Hopefully I'm making this better and not worse. All right. And I guess I didn't add everything that I had before, so let's go back and try to add that. That's what I wanted. Okay. Give me an error here. That's fine. There we are. So what I tried to do was I tried to order it based on the manager ID. Now I probably should have done that in reverse order, but you can see I brought some semblance of order to what I'm working on. So let's put this in descending order. Whoops. Manager ID in descending order. There, we've got it. So you can look at that and see who reports directly to Paul Knott based on, sorry about that. All right, based on this, based on the manager ID, and then based on this in alphabetic order. All right. Again, I brought some semblance of order to this, and I'll leave that up there for a second, so if you want to take a look at it, you'd be able to do so. All right, let's finish up with the chapter then. So, I've done the join on shared columns, I did the natural join, the named column join, the condition join, the inner join, and I believe what was next was the outer join, and that was why earlier I came in there and I made some changes. Now, as mentioned earlier in the chapter, an outer join returns all matched rows and some or all unmatched rows depending on the type of outer join created. All right, so SQL supports a left outer join which returns all matched rows from the left table and any unmatched rows. The right returns all matched rows and any unmatched rows from the right table. So it's the same query, it's just what table you put first. Full returns all matched rows and all unmatched rows. Now it says here, MySQL does not support this, so let's check. Does MySQL support outer joins? MySQL does not support any command named full outer joined. All right, the three joins supported are inner join, left join, and right join. Okay. And of course they give some examples. But let's take a look at what they've got in here and see if we can come up with something that makes some sense. All right. So let's look at this one right here. Like I said, I'm flying by the seat of my pants here, so we'll see whether or not we can get it to work. So let's try this. Let's select we're going to try this in two ways. I'm going to put E dot first name. I'm going to keep it simple. E dot last name. Well, the same ones we've been doing. D dot department number. E dot salary from E dot, in fact, we're going to do department first. D dot departments from departments D, left outer join employees E on D dot department number equal E dot department number. Let's see if it works. All right. You notice we get everything in here, including in this case the null. All right, because what we listed first here was departments. So it said, give me every match in departments, even if there's not a match in the employees. All right. The other way that we could have written this same query is we could have changed the order, and we could have said from employees E, right outer join, departments D, on this. And we will get the same thing. 13 rows, and the last row being null. In this case, we listed first the departments table because it was a left outer join. In this case, we listed the departments second because it was a right outer join. All right? If we did a full outer join, and we'll try that, and then we'll get into the union thing in just a second. But let's try that. Let's try it both ways. So we'll select this from this full outer join. And it says we have an error. I don't know if that's, if it just says full join as opposed to full outer join, or if we don't say the word full. Let's take a look. Full outer join in MySQL. All right. You don't have full joins on MySQL, but you can emulate them. Good. That's a good lead in to our union. All right. So there is no full outer join. So let's start talking about unions. All right. So I'm going to do something here that's going to look a little bit different, but there's a reason for my madness. All right. And we're going to, well, let's put it this way. We'll try some stuff and we're going to see whether or not it works. All right. When you union, typically what you're doing is you're combining two tables together. But in order to combine two tables together, the two tables must be union compatible, meaning they must produce the same number of columns and the corresponding columns must have the same data types. All right. So notice here they've got a list of CDs and a list of discontinued CDs. And you'll notice what they have here. All right. Now, what I'm going to do to show you how to use a union, okay, because we're just about finished. Yeah, we're just about finished with the chapter, is I'm going to come in here and I'm going to look, let's see. I'm going to look at, let's show tables. And we have what? We have departments, we have employees, we have zip city state. Let's describe zip city state. So it has in there what? 4 fields. And then let's select star from zip city state. And right now we've got 4 in here. Okay? So I'm going to create table zip city state 2 as select star from zip city state. I think this will work. It did. So I now have 2 tables, zip city state and zip city state 2. Right now, if I select star from zip city state, I get this. And if I select it from zip city state 2, I get this. In other words, it's the same table. right? So I'm going to make some changes here. I'm going to update zip city state 2. I'm going to set the zip equal to 61072, and I'm going to set the city equal to Rockton. You saw this before, and I should be using single quotes. I'm hoping it's not going to blow up. And the state equal to Illinois, where the ID is equal to 1. And it looks like it works. So let's double check here. And notice I've changed the first one. All right, so I'm going to quickly change the next ones also. All right, so I'm going to just add those two. So now when I select star from zip city state 2, I now have these two. Now, just to make this simpler, and I don't want to, because I'm already going way too long on this, I'm going to delete from zip city state 2, where ID equals 3 or ID equals 4. And of course I spelled zip city state wrong. All right, now when I select star from zip city state 2, now I have just those two records. Now I want to change the IDs. All right, because I already have an ID of 1, 2, 3, and 4 in here. Okay, so I'm going to update zip city state 2, and I already used 5 before, so I'm going to set the ID equal to 6, where the ID is currently equal to 1. And I'm going to do it again, and I'm going to set the ID equal to 7, where the ID is currently equal to 2. All right, so now I'm going to select star from zip city state. Then I'm going to select star from zip city state 2. Now, so far I probably have done nothing but confuse you, but let's create some magic. All right, so create table, we'll call it zip city state 3, as select star from zip city state union select star from zip city state 2. All right, now let's select star from zip city state 3. And notice what we've done. We have used the union operator to create a new table. That new table was a combination of the other two tables. All right, now that may not seem like a big thing, but imagine with our employees table, let's just, again, for sake of argument, let's pretend here that I had 1,000 employees and I was doing them in alphabetic order. And I had to put in all the employees from A through J, let's say. And my friend Mary had to put in all of the employees from K through S. And my friend Zach had to put in all the employees from T through Z. So we each have our tables. They look the same, except, of course, the data is different, but they're all set up the same. Now we can come in and use a union operator to combine those three tables into one table. So what you can do when you use the union operator is you can come in, and as long as the tables are type compatible, you can combine two tables into a new table, three tables into a new table. You can even take an existing table and union it with another table to add those. So if I had the A through J's, we could just take mine and combine the other two tables into mine. All right? I hope what I showed you didn't confuse you, because that wasn't the idea. All right? In the next chapter, which is the last chapter that we'll cover in here, chapter 12, we will be going over probably the hardest concept for most beginning SQL programmers to understand, and that is the idea of subqueries, to be able to access and modify data. So we will have 5 different objectives there. Create subqueries that return multiple rows, create subqueries that return a single value, work with what are called correlated subqueries, use nested subqueries, and finally use subqueries to modify data. And I'll be back with that lecture shortly.